In this video, we'll look at algebraic properties of trigonometric functions. To do this, we'll need a quick review of our trig functions. We'll look at reciprocal identities and then the Pythagorean identities. So recall that for any t a real number, let p xy be the terminal point on the unit circle determined by t. We define sine of t equals y, cosine t equals x, tangent of t equals y over x for x not equal to 0, cosecant of t equals 1 over y for y not equal to 0, secant of t equals 1 over x for x not equal to 0, and cotangent of t equals x over y for y not equal to 0. These are the 6 trigonometric functions. So now consider on the unit circle, we've got all of these trig functions. In particular, I want to draw our attention to cosecant t equals 1 over y. Well, I think it's interesting that we see this y here, because I think we know of another trigonometric function that happens to equal y. And that function's sine of t. Sine of t equals y. So we can just do a quick little substitution and say cosecant of t equals 1 over sine of t. And this kind of makes sense. If you think about the behaviors of the graphs of these two trigonometric functions, you see that they're intricately linked. So we could also say then for secant t, which equals 1 over x, since cosine of t equals x, we could say that secant of t equals 1 over cosine. And then lastly, we could also say that since tangent of t equals y over x, we could grab sine and we could grab cosine. Sine of t over cosine of t. And for cotangent of t, which equals x over y, we can say that equals cosine of t over sine of t. So these are called the reciprocal identities. Now we'll stay on the unit circle for just a minute longer. Recall the equation for the unit circle. Remember, this is x squared plus y squared equals 1. And kind of by the same rationale as what we just did, since cosine of t equals x and sine of t equals y, we can substitute these in. We can say cosine of t squared plus sine of t squared equals 1. Now, in general, when we see this, we'll actually kind of pull the square in. So that's cosine squared t plus sine squared t. And this is unambiguously, these two statements, here and here, are unambiguously interpreted as the same thing. Now, if we took this a step further, because I think it's fine to have a relationship for cosine and sine, but what about our other trigonometric functions? Well, we could easily derive them using this Pythagorean identity. Now, it's called Pythagorean identity because of the Pythagorean theorem. So let's divide everything by cosine first. So if we divide both sides of this equation by cosine squared of t, cosine squared t, we'll have 1 plus sine squared t over cosine squared t equals 1 over cosine squared t. 1 plus, now I'm going to pull that square out to show you what's happening here. And over on the other side of the equal sign. 1 plus sine t over cosine t squared equals 1 over cosine t squared. Well, we know what these are. We just decided that sine t over cosine t equals tangent. So we have 1 plus tangent squared t equals, and 1 over cosine t, that's just secant, equals secant squared t. And then you could derive the last one by dividing both sides by both sides of this original equation, cosine squared t plus sine squared t equals 1. You can get the last Pythagorean identity by deriving both sides of that equation by sine squared t. But I will leave that to you to prove for yourself. And instead, I will consolidate all of this information as the fundamental identities of the trigonometric functions. We have our reciprocal identities. Cosecant of t equals 1 over sine t. Secant of t equals 1 over cosine t. Cotangent t equals 1 over tangent t. That was one that I actually did not mention, but you can derive that pretty quickly. Tangent t equals sine t over cosine t. And cotangent t equals cosine t over sine t. The Pythagorean identities are sine squared t plus cosine squared t equals 1. Remember, since by commutativity of addition, doesn't matter the order in which we write it. Tangent squared t plus 1 equals secant squared t, and 1 plus cotangent squared t equals cosecant squared t.